Welcome to tonight's video on Unit 6, Part 1, finding the limits of functions. First, we're going to talk about how to find the limits of functions graphically. The first type of limits that we're going to talk about are when x approaches infinity and negative infinity. If you look at the graphs, infinity is over here and negative infinity is over here. So if you're finding the limit as x approaches infinity, you're finding the right-hand behavior limit. And if you're finding it as it goes to negative infinity, you're finding the left-hand behavior limit. So you notice here as x goes to infinity, that means as it goes further out here, notice it's going towards 0. And if it's going towards negative infinity, it's also going towards 0. So that's why those limits are the way they are on the graph. So anytime you see the limit as x approaches infinity or negative infinity, you're finding what are called the end behavior limits. The limits as x approaches a number. So in order for the limit as x approaches a number to exist, the y-coordinate as x approaches that number from the left-hand side must have the same value as the y-coordinate from the right. So to find the limit from the left, we say as x approaches c, and we put a negative sign above the c as kind of like an exponent to say the left-hand side. And when we do it from the right, we put a plus sign up there to find the limit from the right. If those two are the same, then the limit is that number. If they are different, then the limit does not exist. So if you look at the graph, as x approaches 1 from the left, notice here's 1. As it approaches 1 from the left, it goes to 1. And as it approaches 1 from the right, it also goes to 1. So that is why the limit as x approaches 1 is 1. If we look at 0, 0 from the left, well, here's x equals 0. From the left, it's going down towards negative infinity. And as it approaches from the right, it's going up towards positive infinity. So therefore, since both limits are infinite, the limit as x approaches 0 does not exist. And the reason it does not exist in this case is because of unbounded behavior, because 0 is what is called a vertical asymptote. So whenever, and we'll talk about this again, whenever you find the limit from the left and the limit from the right, and it's infinite or negative infinity, that means you're going to have a vertical asymptote at that number. All right, so let's look at the graph here. So notice as x approaches infinity, infinity is out here. Notice it's going towards 6. As x approaches negative infinity, notice it's going towards this y equals negative 2. As it approaches 2, so now you got to find the limit from the left as x approaches 2 of the function. So from the left, as x approaches 2, notice it's going towards negative 1 here. And the limit as x approaches 2 from the right. As it approaches from the right, it's 5. So notice these are not the same, so the limit as x approaches 2 does not exist, because the limit from the left does not equal the limit from the right. Same thing for x approaches 3. Now notice as x approaches 3 from the left, it's going towards, negative 3. It's going down, so it's going towards negative infinity. And the limit as x approaches negative 3 from the right is going up towards positive infinity. So that means that the limit as x approaches 3 does not exist. And in this case, it's a vertical asymptote, so that means there's unbounded behavior. Because regardless if they're both infinity or not, it's never going to approach that number. The limit as x approaches -2, well, notice -2 is right here. Notice from the left, it's approaching this number of 4. And from the right, it's also approaching 4. So therefore, the limit as x approaches -2 is 4. As it approaches 5, notice 5 is right here. From the left, it goes to 10. From the right to 6. As it approaches from the left, or from the right, it goes to 6. Therefore, in this case, the limit does not exist because the limit from the left does not equal the limit from the right. All right, and the last part, it asks you to find the values of the function. So f of -3, well, there's an asymptote there, so it's not defined, it's undefined. F of -2, well, -2 is 4. F of 2, notice there's 2 open circles, so that means it's undefined. And f of 5 is actually 10, because that's where the dot is at 10. So those are if you're just putting the value in. So things to note regarding horizontal and vertical asymptotes. If you find the limit as x approaches infinity or negative infinity, the left hand or right hand behavior limits, then that means you're going to have a horizontal asymptote at that point, if it's a number. So you're going to have a horizontal asymptote at y equals whatever that limit is. So the end behavior limits help you to find horizontal asymptotes. If you find the limit from the left and the right of a number, and it's one form of infinity, whether it's an infinite or negative infinity, then you know there's a vertical asymptote at x equals that number. So that's how you tell if there's a vertical asymptote. Now, finding limits analytically, meaning algebraically, we've talked a little bit about this as it goes to infinity. However, we can do the same thing as x approaches the number, is we can plug in that number for x and simplify. However, if the process produces an indeterminate result, then you have to try and simplify it algebraically and then plug in that number again. Now notice it says if it's a piecewise function, you must simplify the piecewise function first and then find the limit from the left and right if C is the changing point, if it has different rules on the left and right. So we'll talk about that. So examples here, notice if you're finding x, the limit as x approaches -2 of the function, and the function is just x squared plus x minus 3, you can just directly substitute in that -2 and get the limit. Now notice here, if you put in 2, it's indeterminate because you get 0 over 0. So then you do the algebra by factoring. You cancel out the x minus 2's, and then you get x squared plus 2x plus 4, where x cannot equal 2, and then you can put the 2 in to find the limit. So let's do some examples. So the first one here, we're finding the limit as h approaches 0. Well, if we did that, we did the limit as h approaches 0 of the function. Notice we'd get the square root of 49 minus 3 times 0 minus 7 over 2 times 0. So we would get 0 over 0 because this is 7 minus 7, which is 0. So that means it's indeterminate. So that means we have to do some algebra. Well, because of the radical, in order to remove the radical or rationalize, we will multiply by the conjugate and see if that helps simplify. So notice by multiplying by the conjugate, the middle term goes away. So you can do the first and the last. So you can do 49 minus 3h minus 49 over, and then you have 2h times rad 49 minus 3h plus 7. Do not distribute. Do not distribute. So then you can cancel out the 49s, and then because of that, you can cancel out the h's. So now you have negative 3 over 2 times rad 49 minus 3h plus 7. So that is what f of h is equal to. So now if you find the limit, and remember, h cannot equal 0. That's what we eliminated, that restriction. So the limit as h approaches 0 now of f of h is equal to negative 3 over 2 times rad 49 minus 3 times 0 plus 7. So that's going to be negative 3 over. So you get 7 plus 7 is 14 times 2 is 28. Now, if you were to find h of 0, that is still undefined because that is a restriction that you can't have 0. Number 4 is a piecewise function. It's a piecewise function. So notice, because it's absolute value, you first want to define the piecewise function. So it's going to be x squared over, and it's negative x if x is less than 0, and it's x if x is greater than 0. And you know x can't be 0 because the denominator can't be 0. So then if you simplify by dividing, here you get negative x if x is less than 0, and x if x is greater than 0. So now you need to find some things. First, it wants you to find the limit as x approaches 0. Now, x approaches 0, it has different rules for the left and right, so you have to find both limits. The limit from the left is 0, because left means less than. The limit from the right is also 0, because if you put that in, you get 0. So that means the limit as x approaches 0 of the function is 0. Now, if I were to find f of 0, it is undefined. There's no definition for 0. It's a restriction. Now, the limit as x approaches 2 of the function, well, 2 is not a changing point, so therefore you can put it in directly in. You don't have to find left or right, so you put it in the bottom, so you get 2. And then f of 2 is also 2. The limit as x approaches negative 5 of the function, well, that is less than 0, so the opposite of negative 5 is 5. And f of negative 5 is also 5. All right, so that is the first part of the lesson and how to find the limits graphically and then algebraically by simplifying. And we'll continue in the next video with some more examples.